In the previous video, we have seen what is statistical quality control, and we have discussed about process control. And these control charts are used in statistical quality control for controlling the process for quality. Okay, so let us see how it is done. And one more thing, it is used to monitor process. Okay, monitor the process for quality when output can be measured as attributes or variables. We will see what is attributes and variables. So these are the different types of control charts. These are continuous. See, control charts are classified into variable charts and attributes chart. Okay, and variable charts are used when you have continuous numerical data. For example, a product is manufactured with a mean of 15 centimeters, so it can be like 15.01, 15.02, like that. There is a variation 14.99, etc. So these are the variables. Okay, so we use variable charts for this, and these are R chart and X bar chart. Okay, so we will see each one of them. This is called a mean chart, and this one is called range chart. R stands for range and X bar stands for mean. Then you have attributes charts like categorical or discrete numerical data. Suppose we are classifying like large, small, medium. Okay, like that we are categorizing it, good or bad. We are just giving we are not assigning variables, just we are categorizing it. In that case, we will use attribute chart, and we will use P chart and C chart for this. So in this video, we will discuss about R chart and X bar chart. Okay, so let us try to understand it with the help of an example. Suppose you have manufactured a product, and maybe you have manufactured a huge quantity of product, maybe 1 lakh. And so according to statistical quality control, we will take samples. Okay, we are suppose you are taking sample of 3 items, and we will take another sample of 3 items, we will take another sample, like that. We have taken total 5 samples of 3 items, and the measurements made are 11.1, 9.2, 11.3, etc. And sample 2, it is 10.1, 11.2, and 9.9. And sample 3, 9.8, 10.2, 9.9. Okay, so these are the measurements of each of the sample. So you can find you can take the mean of this, that is 10.5, mean 11.1 plus 9.2 plus 11.3 divided by 3, it is 10.5. And the range means the maximum minus minimum. So in this case, it is 11.3 minus 9.2, it is 2.1. Similarly, for sample 2, X bar and R, sample 3, X bar and R, sample 4, X bar and R, sample 5, X bar and R. Okay, so we have got R and X bar. Then for constructing the R chart, we will take the mean of this R. So that is 2.1 plus 1.3 plus 0.4 plus 1.2 plus 2.3 divided by 5. So it is 7.3 by 5 or 1.46. Similarly, and then okay. And for X bar chart, we will calculate the center line, that is X bar bar. Again, it will be average of 10.5, 10.4, 10, 10.5, 9.8, that is 10.24. Then for R chart, you have the upper control limit and lower control limit. For constructing the R chart, we need these values. And this upper control limit, that is UCL, is given by the formula is D4 into R bar. And out of this D4 is obtained from charts. Okay, right? Suppose the value is 2.57. We have taken from some charts. Okay, there is some values out of which you can take the required D4. So suppose it is 2.57. So 2.57 into R bar will be 3.75. And lower control limit is D3 into R bar, that is, so D3, here the value, let it be 0. And into R bar is 1.46, so it is 0. Similarly, for X bar chart, the upper control limit is X bar bar plus A2. This is also taken from a table of charts and tables. You can obtain it. Let its value is its value be 1.02 into R bar, that is 1.46. So you will get 11.73. And lower control limit is X double bar minus A2 R bar is equal to 10.24 minus 1.02 into 1.46, that is 8.75. Okay, so we have got the upper control limit for X bar chart and R bar chart. So, okay, and we can plot, see, we can construct an X bar chart and R bar chart like this. Okay, so in this case, so X bar chart is, let us first construct the X bar chart. The upper control limit is 11.73. So okay, we can draw the chart here. Okay, so lower limit is 8.75 and upper limit is 11.73. Okay, and then see, first X bar is 10.5. Okay, it is somewhere here, and then you have 10.4. okay, this also will be in this, and then you have 10, okay, 10.5 and 9.8, all are within these two limits. Okay, so you will get a chart like this. So you can see, so this is for a different value, but you can find the X bar bar and upper control limit. You will get a chart like this. So if it doesn't, see, if it crosses this limit, okay, then that means the process is not under control. But in this case, the process is under control because all are within the two limits, that is 11.73 and 8.75. okay, similarly for R bar chart, okay, you have the upper control limit and the lower control limit and the mean, and you can plot the values. So if it does not crosses the limit, so that means it is under control. Okay, so this is how you construct X bar chart and R bar chart and check for the process control, to check whether the process is under control or not. So this is one sample problem you can try on. You can construct an X bar chart and R bar chart.